Hello, welcome to the live cloud cover episode. In case you missed it during that segment, my name is Steve Marks.
And I'm Wade Wegner.
We're going to do this live, which is fun for us.
Yeah.
This is
first time in front of an audience.
We have a live studio audience. People on the web, they don't know that, but there are a lot of people here eating who are going to hopefully also listen to us.
Actually, it smells quite good.
Learn some things. It does smell good. I'm hungry. This is what, the 68th?
68th show.
Episode?
Yeah.
We should tell people a little bit about the show. Yes, thank you. No, applause is appropriate. Yeah. More of that. That's why we should have a live studio audience every time we do this.
Every time.
So this is a show that we do every week about Windows, Azure.
The platform.
The whole thing.
Yep.
Everything. We cover everything that happens in the Microsoft cloud. 68th episode. We've done live ones before, but not quite like this.
Nope.
So this is fun.
Yeah, so this will be good. So typically the format goes, we start with some news. So we'll cover what's happened over the last week, talk about some of the larger news items. We'll break into a feature where we go through some demos and cover one topic. Today we're actually going to go through about 3 different topics. So we've got 3 demos. And then we have the best part of the show, which is the tip of the week.
Yeah.
Actually, the best part of the show is the moments before the tip of the week.
Yeah.
But everyone will find that out soon.
We'll explain that when we get there. But,
so why don't we get started and we'll start
news.
with the news. So in case no one has heard, there have been some big announcements this week. So some large announcements in the platform, in case you didn't know.
Yep.
So up on the Windows Azure blog, we've gone through some of them. So real quick, there's a bunch of new developer experiences. Last month, we released a new SDK and tools for Visual Studio and .NET.
Yep.
This month, we've announced support for Node.js.
Yep.
We released some stuff for Java.
And a new, revamped sort of development center that sort of talks about all those things and has tutorials and easy links to download the right things. It's nice, but you've heard a little bit about that.
Yeah. And in addition, there's been a service release for SQL Azure.
Yep.
And in particular, some of the things to cover has been an increase in the database side. So I think everyone's heard that it's increased to 150 gigabytes.
And you know the pricing deal with that? That they did you cap at the 50 gigabyte price, which means you can go from 50 gigabytes up to 150 gigabytes, and that 100 gigabytes is basically free.
That's awesome.
So yeah, that's a pretty good value.
It's great. We just saw an interview from Sheehan, who talked about SQL Azure Federation.
Yep.
And we've got a refreshed SQL Azure management portal, which has been updated, allows you to do quite a bit of stuff, and David showed that earlier. There's been updates to the DAC import and export CTP so that you can import, the backpack in and out of.
I get confused with all those names.
The backpack.
Yeah, something like a backpack.
And then the last thing we wanted to mention was the collation support for creating databases. And I'm pretty sure that this support is through the SQL Azure management portal. If you create your database through the Windows Azure platform portal, I don't believe you can set the collation for the database. I could be wrong, but it's worth noting. But some great.
You could never be wrong, Wade.
some great new releases there. The last thing we wanted to talk about here too was the Port 25 post. So why don't you mention this?
This is kind of a collection of all the things that we've done in sort of the openness, sort of interoperability. We sometimes say. I prefer the word operability to interoperability. There are a lot of things that work. It's not really about them sort of having to talk to each other. Mm-hmm. It's just all these things work. And so there's some stuff about Node.js here. There's also some stuff about running MongoDB in Windows Azure. And so some folks from Microsoft and from 10gen, who's the company that does most of the work with MongoDB. Mm-hmm. Jointly, we sort of put out some stuff that they've released that just sort of helps you to package up Mongo and run it in Windows Azure. Connect that up with your Node.js application because that's probably a popular use for Mongo. Although you can also do that in your .NET code or something else too. That's in there. There's also some stuff about Hadoop, Solr, and Lucene. Running sort of the native Java Solr or Lucene. There's some documentation about that, some stuff about memcached. It's an extensive post. It's kind of just a roundup of all these different things that we've done, kind of around that openness theme. Yeah. So very cool. Should hopefully help us to get the word out about Windows Azure being an open and flexible platform, and not just about .NET. Even though yes, lots of people like to do .NET on Windows Azure, including me.
Well, great. Well, since you did mention .NET, I think transitioning over to the features, we wanted to first highlight some things that you can do with .NET and some of the services that are provided on the platform. Scott Guthrie actually mentioned earlier this morning that there are a number of services. He didn't show them all this morning, but there's a couple of other services in addition to Service Bus that are provided as part of the platform. And two of them that we wanted to cover here today were the Access Control Service and the Caching Service. Access Control Service is a way to federate your identity and to interact with social identity providers and even corporate identity providers. Yep. So it's a way of essentially offloading the responsibilities of managing identities to existing identity providers. And so then the Access Control Service really becomes that point that you write your code against so that it manages all the complexity for you. And so this is really nice because when we start to build out our applications, we don't have to do things like use membership providers or role providers in order to create and store and manage our own identities. Because, I mean, one of the #1 security vulnerability spots is going to be where you store usernames and passwords. Yep. In terms of support.
Are you encrypting them?
Yeah, are you encrypting them?
Sufficient salt, like I mean, there's a lot of that stuff to worry about. And then, of course, you have to do it like 5 different times because you have to do it for Facebook and for OpenID and for Live ID.
Well,
and
yeah.
Yahoo.
So one of those challenges is when you start interacting with Facebook, it's going to have one method, one protocol for interacting with Facebook. Yahoo is going to be different. Live ID is going to be different. And so now you're responsible for developing against each one of these different protocols. And so the Access Control Service just makes this a lot simpler. And then, so that's the first one that we'll talk about. The second one is the caching service. And this is a distributed in-memory cache. It actually runs up in Windows Azure, stores everything in memory. So it's really fast in terms of gets and puts and so forth. And one thing to note is you do call it over the wire, so you actually will be communicating over the network to your distributed cache, but there is a local cache option as well. And so you can turn on local cache so that the data that you grab out of the cache or that you put into the cache can actually be stored then on the compute instance in memory, so that some items that you really want very quick access to, you can use the local cache for, and it's right there on the box. In fact, you can put any .NET object into it as long as it's serializable, but if you use the local cache, it doesn't have to serialize or be deserialized. So it's a really, really fast way to get a quick get operation on the cache. So we're going to go through both of those today. So let's do it. So here I'm on the portal, and I've already gone through and created the service namespace, but I haven't done anything with it yet. We actually created it about an hour ago backstage.
I saw him do it.
Yes.
I vouch for this.
Yeah, I mean, we'll start another one. We can create, I mean, it typically takes about a minute or so. So this would be, let's call it live cloud cover. And choose a region. And you can turn on the cache as well, change the cache size, and we'll go ahead and create that. So this will take a few moments, but what we're going to do is for the demo that I'm going to run here today, we're going to use the Cloud Cover Live namespace that's already been provisioned. So when using the Access Control Service, you can select your service namespace, hit Access Control Service, and it's going to actually take you to another portal. Now, one of the reasons it does this is the Access Control Service has a management endpoint that you can communicate over HTTP with, and you can use multiple identity providers to connect to it. So you can use your Live ID to access it. You can use your Google ID. You could use Facebook, etc. And so that's why it does flip to another portal, because this portal is available across multiple identity providers. And so the very first thing that I'm going to do is configure the Access Control Service by specifying what identity providers that I want to be able to leverage with my application. So I'll select Identity Providers and click Add. Now, there's a couple of options here. I can add a corporate identity, something like Active Directory through Active Directory Federation Services. I would provide something like the WS Federation metadata XML file or the URL to point it to. I could select Facebook. The reason I'm not going to select Facebook is I'd need to have a Facebook app where I would get the Facebook secret and so forth. So I'm just going to skip that for today. And then Google and Yahoo. And Google and Yahoo are very, very quick and easy to set up. You can make some customizations if you want to, but just with a couple of clicks, now I've said that I want to be able to use Yahoo with the application that I'm gonna use the Access Control Service with. Now, once I've selected the identity providers, go ahead and click Google here as well, real quick. Now what I need to do is set up a relying party. A relying party is really nothing more than the application that's going to be utilizing the Access Control Service at the service namespace. So I'm going to have a web app that we're going to run here in a moment. And so I'm going to add a relying party for that web app. I'm going to call it just my app. And you could import settings if you'd want to, but I'm going to just go ahead and type this all in. You'll want to specify a realm, and so this is the realm that my app will be communicating with. So the syntax would be URN, and I'm just going to say URN my app. So this is going to be the realm that my application uses. And then since this is passive federation, there's going to be some HTTP redirection going back and forth. We want to know what the return URL is back to our application. And so we'll see this when we run the app. We'll see some redirection in the app. And so since I'm going to run this locally in the emulator, it's just going to be at localhost port 81, because when I run it within the local compute emulator, it's going to be surfaced up through port 81. There's some other options as well if you need to change token formats, etc. I'm going to go ahead and leave the defaults as they are and save this. So I've got my realm created now. The last thing I need to do is specify some rule groups. Now the rule groups are what are responsible for taking claims from third-party identity providers and transforming them into the claims that my application is going to use. And so let me just go ahead and show you what this looks like. So
yeah, this is part of the magic, I think, of ACS, and that we talked about how we're going to use Facebook, Google, Yahoo, whatever. We're going to sort of use all those identity providers, and then there's this question of, okay, what does my app have to do to accept those various credentials? And this is where we let access control do a bunch of work of basically transforming whatever it is that you get from Yahoo versus Google versus some OpenID, Live ID, and give us sort of a consistent set of claims back so that we know somebody's logged in and we know whatever sort of pieces of information we choose to kind of get for there.
Yeah. Now, you could do this one at a time. Like I could create one rule for an identity provider for a particular claim and what it maps to. You can also choose generate, and based on the identity providers that I've already selected, it will allow me to just go ahead and generate some default rules for my application. And actually, for what we're going to show today, these rules here are perfect. So basically, you'll see that we'll have some claim issuer of Google, and what it's going to do is essentially pass through that email address claim back through to the token that we'll use within our application. So go ahead and save this. And so now I've got my rule group defined. At that point, I've configured the access control service. So there's really nothing more to do the access control service. However, I'm going to need to leverage this within my application. So I'm going to come down to application integration. And you'll notice one of the things that gets surfaced up for this service namespace within the access control service is the WS Federation metadata URL. And so I can use this now within my app using some tooling within Visual Studio to get things imported quickly. So let me go ahead now and flip over to this Hello World app. And now this Hello World app is really the same Hello World app that Scott Guthrie showed when he was interacting with storage. And so let me go ahead and run this real quick before we do anything else, just to demonstrate what this app is, and just.
I already see one difference between.
Yeah, I know there is one difference, and I was gonna call it out as soon as. But it's
Jeez,
purposeful.
Wade, you lie to these people while they're eating lunch.
All right, so this is the app that you saw earlier, where Scott had uploaded. It's the same images that he had uploaded earlier. The one change that I did make is I'm basically writing out the current time and formatting it basically GMT and making sure that we can see seconds. Now we're going to get to that in a moment. That's actually part of this demo. So that is one change that I made.
This is foreshadowing. That's what we're doing right now. We're foreshadowing future demos.
So note that when I load this up, right now it's not asking for any sort of identity credentials. Basically, this application is open to anyone that browses to it. So we're going to make a couple of changes so that we can use the access control service to log in.
We don't want just anyone seeing our collection of koala photos. It's actually.
So what I've got installed here actually is the Windows Identity Foundation SDK. And as part of the SDK, you get some tooling. And right here, this is an add STS reference, and that's a security token service. And essentially, when I run this, it's a wizard that I can use to help set up my application to interact with the token that comes back from the access control service. And so when it asks for the application URI, this is again where I'm going to specify the realm that I ended up creating. So it's going to be URN my app. And I'm going to continue. It's just prompting me that I should be doing this over HTTPS. I'm going to ignore that. And then I could say no STS, create a new STS in this project, which is kind of nice because then you can replicate the function of an STS locally. But in this case, I'm going to use an existing one. And if you recall that Federation metadata URL that I copied out of the access control service, here's where I'm going to paste it in. And so when I hit next, going to go through a couple of these steps. And here you're going to see that from that federation metadata URL, it's going to pull in a couple of different claims that my application will be able to use. So go ahead and click Next once again and Finish. And when running Finish, there's a couple of things that have occurred now. So an assembly has been added. Where is that assembly? System. OK, maybe it wasn't added. All right. Well, one thing I do know that it did is it updated the web config file. At the end of the web config file is now a Microsoft.identity model section. And in here, you're going to see a lot of the same things that we ended up configuring up within the access control service. So here's the Cloud Cover Live service namespace that was created. You can see here's the rest of the URL, accesscontrol.windows.net. We've got our claims that have been imported into here. This is something we saw through the wizard. And then we also have the audience URI, which is the realm that's been specified, and some other things as well. This is a thumbprint for a certificate that ACS automatically created for us and so forth. So with those changes, there's one other thing I need to do, and that is under system.web, I need to change the HTTP runtime. If I can type HTTP runtime to validation or request validation mode equals 2.0, and that way it'll run properly. So let's go ahead and run this now.
What does that report?
It handles how the validation. You know how when it does a post back, you can say like, oh, there's a vulnerability here. Don't post it back into the form.
And this is because when we get returned to our app,
it does redirection back to the application.
Some XML goo in there, or
it puts the token response in the body of the response. So you'll end up getting the token out of it.
Got it.
So now here's this is called a home realm discovery page, and by default, what it's doing is it's actually running off of the access control service. So if you take a look there, it's Cloud Cover Live.access control, and it's called home realm discovery because we're going to choose the home realm or the identity provider that we want to use to log into the service. One thing that I should point out is this is the default behavior. So the home realm discovery also can be interacted with through just a REST service, so that you can get a JSON feed that comes back that also has the Windows Live ID, Yahoo, and Google. So you can embed this into your application if you don't want to have this very pretty UI. You can make it consistent with however you would want to render some sort of login experience. And you just basically
have to build a page that has links, right?
Yep,
I mean, that's
exactly.
all these things do is sort of go off somewhere with a particular, probably somewhat nasty URL because it's probably got some return information.
Let's take a look. We can actually expand
this. Let's find out how nasty that URL is.
So if I click Live ID, we're going to be redirected, and you see now I'm actually logging in to Windows Live. And so I'm going to use oh, look at that.
Oh,
that is...
This is my fault.
This is your fault. So Steve likes to use the Dvorak keyboard.
Yeah, this is
and
my
I
fault.
do not use Dvorak. Is that going to fix it? Phew. All right.
I told you it's easy to fix.
It is easy to fix.
Yeah, we had this moment where I was sort of typing things on Wade's laptop, and I said, it's just so slow, I can't type code.
Yeah, so he switched it to
QWERTY layout, you know?
So we kind of missed the magic. I'll log off and do that again. But I logged in, and a bunch of things happened. We had some HTTP redirection where essentially the token that was emitted from Live ID after I logged in was then passed over to the access control service. The access control service can take that token based on the rules that we had defined. It was able to transform it then into the token that my app understands, and then it was able to send back that token as part of a response back to the app. So all that happened very quickly.
So we were at this app. We said we want to log in.
Yeah, let's do it again. I'll log in with a different identity provider.
Okay.
So go ahead and start this up again.
Because the flow is actually simple. It sounds sort of complex, but I mean, it's really, look, somehow you've got to get over to Live ID or to, what are we going to do? We're going to do Google?
We'll do Google.
So you have to get over to Google to do this. Google returns you to access control, which does a transform and then returns you back to the app, right?
Yep.
And so that's it. So I mean, it's really, there's the app, there's access control, and there's wherever you're logging in. Those are the three things, and the flow is actually fairly simple.
Yeah, and I paused here because with some of the identity providers, you actually have to opt in before you're trusted to just return these credentials. So here I'm going to go ahead and say allow, so that it'll send it back, and we'll be logged into the application. And one other thing worth pointing out here is notice with Google, it actually has my name. So my name is one of the claims that Google will provide. Live ID doesn't actually have that claim. So there's some other information that you can dig into, ways that you can use like a SQL Azure database or Windows Azure table storage as a repository for additional metadata that you may use to then enrich the token with additional claims so that you have some consistency within the app. So that's it. So that's how easy it is to get the access control service set up.
This is pretty easy.
So now the next thing we wanted to show is how we could interact, basically incorporate the caching service as well.
Yeah,
and
it bugs me that there's that clock on that page.
Yeah, exactly.
And it's always changing.
Always changing.
That really annoys me. Can we do anything about that?
Yes, we can. So what we're going to do is we're going to use the Windows Azure caching service and turn on page output caching. So essentially what we're going to do is we're going to cache the output of the page, and we'll set it to like 10 seconds. And that way, when we start refreshing the page, we won't see it change every second. It'll take 10 seconds for that page to
that'll
to
make
refresh.
me feel much better.
Much better.
So caching can be used for, almost anything, right? Anytime you need to be able to store something in memory so you can access it quickly and then sort of retrieve it, particularly if you want that to be shared across, you're running lots of instances or even different apps and you want them to all share that same data, you can use caching for that. I think probably one of the more common cases is to use caching for session state.
Yeah.
And so for stuff that's kind of associated with that session, but maybe short-lived, expires later or something. In this case, we're going to do it for output caching, which is another great use of it. But I don't want people to feel like this caching thing is only about output caching. It's a general in-memory caching service.
Yeah, we decided to do output caching because, honestly, people don't demo
Nobody
this very
ever does
often,
that demo. So we like to break new ground.
I'm installing a NuGet package, the Windows Azure .caching. So this was actually just released late last week. And what this will do is it'll update my project with everything that's required. This time I know for a fact that there are certain assemblies that were loaded in there. So we've got the caching client, the caching CLOR, and the Microsoft.web distributed cache. So these are the core assemblies that will get loaded in that allow us to interact with the cache. And then also our web config file has been updated as well. So if we come down to the end, now we've got essentially a data cache client section here where we're going to update this to interact with our caching service. So to do that, let's go back up to the portal, and I'm going to go back to our cache now for Cloud Cover Live, and look at that! Our live CC cache and ACS namespace are now ready for us. But I'm going to use.
It should be. It's been quite a while.
It has been a while.
It's really that's not that long of an operation. No. That's a minute maybe.
Yeah,
or something
it's a minute or two.
As a provisions, yeah.
So with Cloud Cover Live, there's some information over on the right side, some properties that we're gonna end up leveraging within our app. The first to note is this service URL right here. Essentially, this is going to be the URI that I use to interact with the caching service. If you think about it, the caching service is an endpoint available on the internet, and I'm just going to be interacting with it. Now, for good performance, you want to make sure that you create your cache in the same data center as the apps that are running it.
Right.
Certainly, you can access it from outside of the data center. I mean,
we're going to
case
do that
in point,
now.
We're going to do that now.
Yep.
I'm going to run it from my machine here and interact with it. But I'm going to go ahead and grab that. And back in our web config, where it says to insert this endpoint, I'm just going to go ahead and paste this in. And then go back here again, and then I'm going to get a token here. So essentially, every time I make a request to the caching service, as part of the header, I'm going to embed this authentication token so that when the caching service receives the request, it can validate that I'm authorized to go ahead and make that call. And it's worth pointing out, too, here that there's two here because we also have an SSL endpoint as well. If you consider that we're just embedding that token into the request header over HTTP, probably not the most secure way to do it. So you can use SSL in at least that way.
We should put it in email. That would be really
put it in email.
Super secure.
Great. All right, so we've got our cache set up. Now let's go to our controller. Where's my controller? There it is. And on our index here, I'm going to go ahead and say output cache. And then I'm going to specify the duration of 10 seconds because having that refresh each time really upsets Steve.
It really upsets me.
And we'll run again. So the behavior we should see is every time we refresh, it's going to take 10 seconds for that value to change.
Right. Until 10 seconds passes, we're going to keep getting the same cached page. And that's basically because in our app, we look at the output cache and we decide that it's appropriate to cache for 10 seconds. We store the page in the caching service. And then the next time we load the page, we say, oh, it's still within that time. We just fetch it from the cache and kind of display it again.
All right, so
let's find out.
Yeah, so let's refresh. Okay, so 10.
It's a little bit small. If people can't see it, it's 3 seconds on there.
Make it a little bit bigger.
Oh, that's much better. Okay. Now how long? It's been 10 seconds, hasn't
It
it?
has been 10. So 13.
So 13, and then as we refresh, it doesn't change, and then when about 10 seconds has passed now, that would have been so much cooler if I'd timed that right.
There we go.
There you go.
So refreshed.
Yeah.
So that's essentially what we're using now is the caching service as part of our page output caching. And so it's a good usage of the caching service. The output cache is actually provided by that distributed web cache assembly that was added to the as part of the project. That assembly can also be used for the custom session state provider if you want to use the caching service for session state.
Yep.
So
it's cool. It's amazing how easy it is. It's basically just some config settings, and then you're done.
It's cool.
All right,
so
let's move on.
All right, so next.
We've got a couple other demos to do. I think the next one we're going to do is Node. Should we just switch
let's
seats?
just switch.
We're going to switch seats. That sounds fun. See how coordinated that was? This is where we need the Dvorak keyboard layout. But we're going to do, I just kind of wanted to show a little bit more about Node and specifically about using storage from Node. So using Windows Azure storage from Node, because part of what we released that you didn't see Scott do, because he sort of just stopped at kind of a hello world of Node, is we also released libraries that let you call into the storage services from Node, and other services are coming in the future. And that library is on GitHub, and it's also in NPM, so you can just sort of install it that way.
NPM is the Node package manager?
That is correct. Okay, so let's make an app. We're going to call it Blobby, because we're going to use some blobs. We're going to add, you've seen this part before, so I'm not going to tell you much about this. But this is kind of where the last demo stopped. So again, sort of picking up from where Scott stopped, we had this. It's a hello world.
I think he modified server.js, right?
Yeah, I'm not going to do that. But it's just sort of a basic hello world. We could run it now. I don't want to. I want to do something cooler than that. So I'm going to do npm install Azure. So what this is going to do is it's going to grab the Node package for the Windows Azure libraries. So it's going to pull in all the stuff I need to talk to blobs and tables and queues. And there will be more to come there. I'm also going to install Express, which is a web framework, a sort of lightweight web framework that's pretty popular in Node. And we're going to build the app with that. So
Let's do a quick dir, show us what just got pulled down.
yeah, show us what happened. Nothing. No, but if you look in the Node modules directory, now you see those sort of pulled into there. So I'm going to run something from there. I'm going to run the Express command, and this is a little scaffolder that comes with Express. So now actually a lot has changed. It's done a number of things, and one of the things it's done is it's modified my package.json file to say I have a couple dependencies. One is Express, which I already obviously have. One is Jade. To make sure that Jade comes in, I'm just going to run npm install to pull in all the dependencies.
Yep. And so that reads the package, installs all the dependencies based on that.
Yeah, exactly. And see this file, app.js, that's what Express created. My application is set up to use server.js. I could actually change that by modifying web config and doing some things, but I'm just going to delete the one that I had and rename app.js to server.js. And at this point, we have something looking like an app. This is what an Express app looks like. This is sort of a kind of basic app that's running. We're going to have to make this change. Scott talked a little bit about this, but you always want to use that port environment variable to make sure you're listening on the right port.
Right. And that's because we could have a couple of instances of Node running, and we want to make sure that it gets resolved to the right one.
Yep. If we're using a web role, which is what we're doing here, IIS is actually managing Node processes, and it gives each a different port. They all kind of listen on that. It sort of manages that process lifecycle and sending requests to the right thing. So we're going to listen to what it has to tell us by using that port environment variable. So now let's build some quick UI. Should we build the UI first? Let's do the UI first. So this is Jade for people who have never seen this stuff before. Jade is kind of a language a domain-specific language for writing HTML. Let's see, can I get my Dvorak keyboard layout? Otherwise I can't type. Okay, there we go. Yeah, and then I forgot immediately which layout I was in. So what I'm going to do is we're going to pass some blobs in here. And I'm going to enumerate through them, and what we're doing is recreating exactly that storage thing that Scott's did and that we just looked at in sort of the .NET one. So we're going to do an image, and we're going to set the source equal to the URL of the blob, and just for awesome styling, we're going to make sure that they're small, and we're going to give them a little margin so they're not all crammed together. Okay, so that's some UI that assumes that somehow we've got some blobs. So now we're going to go modify the code that's sitting behind here and use Windows Azure Storage to get those blobs. So I'm going to pull in the dependency of Windows Azure, and we're going to do create blob service dot list blobs. We're going to pass in a container name and then a function that's going to get the blobs. And in there, we're going to render index. We're going to call it blobmania, and we're going to put those blobs in there. So just really quickly, what this did is these are sort of parameters that are passed into the view, if you want to think of it that way. And I think we might have a functioning app at this point. So let's try running it. Oh, in this window, I have a different keyboard layout. It's recipe for success.
So now you're just running it locally outside. You're just running Node directly.
I'm not actually running in Windows Azure. This is I'm glad you mentioned that, because this is actually an important point, which is that the library for talking to Windows Azure Storage, you can talk to Windows Azure Storage from anywhere. It doesn't have to be an app running in Windows Azure. In this case, we're actually not yet running in Windows Azure. I'm just running Node on the command line and launching this. I could run this on any web server, in any cloud, anywhere I wanted to, and still make use of blob storage in Windows Azure, which there are a lot of compelling reasons to do. And different keyboard layout again. And it doesn't work at all. So, you know why this didn't work? One thing that isn't set for me if I'm running outside of this. So the way the library works, if you notice, I didn't pass in any credentials. I didn't give it a blob storage account. I didn't give it a key. What this is telling me to do is that I should do that. I should give a storage account and a key. I want to use development storage instead, and there's a little trick to doing that, which is to set an environment variable. So if I set the emulated environment variable to pretty much anything, actually, I don't even think it has to be true.
It just checks that
I think you
there's
could
a variable.
set it to 0, actually.
As long
it's
as
really
there's an environmental variable emulated.
The presence of the environment variable. Now it's going to hit local storage instead. So there's nothing in there, so maybe we can add something.
Yeah.
So we'll go to container here locally, and we'll upload from. This is scary. This is Wade's computer. Who knows what pictures are in here?
Okay, good. So this is
Years of War pumpkin.
This is actually a pumpkin I saw when I was trick or treating. So
great. Okay, so that's it. So this is now sort of listing the blobs that are in there. The other part of this that we had in the earlier demo was Scott doing kind of uploads.
Yep.
I think we're going to skip that. I'll put this code up on my blog, which is just smarks.com. So if people go look at the blog, I'll have sort of the full source code that also handles uploads and kind of putting those into blob storage. But it's largely the same thing. It's just a little more of that code. So the last thing that I want to do before we wrap this up is to actually use cloud storage.
Yep.
So here we just set emulated to true, and now it's just running locally. If we want to use cloud storage, we should have a little snippet here. And this is doing what that error message was suggesting I do before, which is it's setting a storage account and a key. And this is the same storage account and key that we used in Scott's demo earlier, in the demo we just looked at. And notice that I'm deleting the emulated environment variable. So no matter whether this is set or not, I'm overriding it and saying, no, forget the emulator. I want to use real cloud storage. At this point, we're going to go over the internet, HTTP, hit the real thing. And so let me just launch this again and refresh, and now we see all those blobs that were uploaded previously when Scott did this. I think that's about it. Let's start it here just in the emulator. I don't think we need to go deploy this. I actually did deploy it. If you guys want to, you can go to smarksblobby.cloudapp.net. I optimized for ease of people understanding what the URL is. So you can go up here if
you've
you
actually
want.
set it up.
And it is actually, this is running in the cloud, and this is using
you can upload?
the actual storage thing. You can try to upload. So let me go grab a picture, maybe this logo. Yeah, right. So like I'm going to open a page for the internet to upload any image they want. Not going to happen. So that one's slightly edited. Here's the same thing running, just the one that we had locally here, just running in the Windows Azure emulator. So now it's actually using the emulator. I could be running multiple instances. I could use all the stuff that's available sort of within the emulator and within the cloud. just call publish and it would go.
Great.
So that's about it. That's sort of the basics of going with Node. There's a lot more that you should learn about Node, and it's up on that development center.
Awesome. Great.
What else could we do? I feel like we haven't looked ridiculous enough during this.
Yeah.
Is there anything we can do?
Yeah, we've got one more. And this is why we brought the Connect up here as well.
Yeah.
So the next demo, one thing we wanted to talk upon is the fact that when you start working with Windows Azure, a lot of the management operations that you have seen us do in the portal. So you saw Scott do a VIP swap.
Yep.
We've basically done operations like listing out hosted services. All these things are available through an API, a REST API that anyone can program against. Essentially, as long as you have your certificate registered and you basically formulate the right request, you can start interacting with these REST APIs. And to reinforce this, what we thought we would do is show how we could interact and basically create our own management portal using the Connect and interact with it.
To be the best.
It seems like a very reasonable use of time. I mean, if someone wants to manage their hosted services, what better way to do it than with the Connect? So why don't we go ahead and get this thing opened up?
Yeah, I'm just going to close some stuff to get it kind of out of your way.
Right.
But then why don't we switch again, and I'll let you drive this.
All right.
We racked our brains. We were just like, how could we improve on the management experience? And it was like, well, there's all this mouse stuff you have to do.
I know, you got to click around a lot.
And I don't know. It just seems like such a hassle.
Yeah.
I'd rather just stand up and wave my arms around. So that's what we did.
So at any rate, we're going to post all the source here. So we'll make this available. We don't have a lot of time left, so I'm not going to go through it. We will touch on one thing, but why don't we just go ahead and run this and let's get it started. So
I'm going to get out of your way for this one.
All right. All right.
I want no part of this.
So, this is this is Cloud Cover Minority Report essentially.
Yeah.
So
yeah, it's just as cool as that.
Dang. So if I had, so I guess I reset some of the instances here. So if there were 3 more instances deployed or hosted services, then I'd be able to page and swipe back and forth. So you just have to trust me.
No, right. And if you just had the right thing, then you could do this, and it would scale out. And
I did notice that a new gesture SDK was
restart.
released recently. All right. So you saw that I selected one of my hosted services. Now, let me go back real quick and point something out. To load this up, essentially, all I'm doing is doing a.
That doesn't do anything, Wade.
I know it's not doing anything. I know. I want it to.
Swimming.
I'm basically calling the API and getting a list back of my hosted services. When I select it, I'm getting now a subscription, or rather an identifier for that hosted service, and I'm making another call where here you'll see I've got a bunch of information. So here's the role name, the OS version, here's my name, the label, all this stuff, right? You can see I've got 2 instances deployed, and so forth. So over here, we've got some operations, things that we can end up doing. So again, like right now I can go ahead and scale up. So I'm basically saying go ahead and deploy another instance of this application. And now this doesn't refresh that quickly, but let's see if we can. All right. I'll come back to it. We'll see this. We'll flip over to the portal in a moment, and you'll see that it's now spinning up another instance. I could perform a VIP swap. I could resume an instance if I had stopped it. Things like that. So just kind of a fun way to show that just through these gestures. What we really wanted to do for a VIP swap was support a gesture like that. Where like flip it. But this is what we were able to accomplish. So, actually, let me flip over real quick.
So this is just a preview of what the Windows Azure portal is going to look like
in the future.
Year.
Yeah, exactly.
A little sneak peek.
All right. Do I have a? There we go. I actually have one open.
This is a good time for me to distract them while you. Okay.
So
never mind.
There you can see that one of them is updating right here, right? So it's basically scaled up from 2 instances to 3. So we were able to send that operation to the service management API.
It feels awkward now that you're not doing this.
I know.
While you talk.
I should pull the app back
I feel
up.
like you should just do that for
All right.
So I have seen I really did see him scroll like that.
Yeah. So there's kind of the gratuitous way of interacting with the Service Management API. One thing we wanted to reinforce is that these are just HTTP calls, right? So that's all that the app is doing, and we thought we would do that by pulling up a library that Steve has released up on GitHub.
Yeah.
That it's for this is your Ruby one, right?
Yeah, this is Ruby. It's a Ruby gem. You can actually just do gem install waz dash command if you use Ruby. And you'll get a little command line tool called waz that lets you do things like this one, which is waz show application and then a name. It makes a call to the same management API that we're using in that Connect demo, or that you use if you use any tool that does this. It's just going to do that. And so here you can kind of see the URL.
Yep, services/hosted service, and then an argument that's,
and then the name,
passed into it. Yep.
With some embed details. And if we do have that queued up, this is what it's calling. And this is it, just for some variety, just to sort of show that this really is just a REST API. It's pretty simple. Yep. Here's the Ruby version. It's using a library called REST client, and you can see it's just constructing that URL. It's making a post request or get request depending on the kind of thing that it is. It's setting a special header. This MS version header. It's passing in a certificate. That's sort of the key to this, is the way that authentication works is with a certificate that you can either download from the portal on that publish settings thing, or you can create your own and just kind of upload it and go either way. And that's it. And then it's just basic REST commands. It's really a few lines of code to call this.
Yep.
Really, I hope this demystifies it quite a bit.
Cool.
So that was good. So this is it. This is the moment we've been waiting for, right?
This is the moment.
This is the moment. Okay, so we have to explain this a little bit, which is that on the show every week, it started really early in the show. We ask our editor Bob, who's one of the most amazing editors. Well, he's probably the only editor I've really ever worked with, so I guess it's not saying much, but he is really amazing.
He is amazing.
He does a really good job. We ask him for something absurd to sort of introduce the tip of the week, and he puts together a little video for us that does that.
It's a shame we didn't have more time because we were running behind schedule. The commercial that preceded the show actually had a bunch of the tip of the weeks.
Do we have that online?
So we're going to be posting that online. So I just wanted to say, if you go to the event on Channel 9, that's actually already up there. So
you can see some of his best work.
You can actually take a look at it if you like.
But this time, of course, we're doing the show live. So Bob is standing by backstage.
He's backstage.
He's waiting for us to tell him what he should throw together, and then in real time, he's going to put it all together into a little video thing.
Yeah.
It's not a video; it's live, and I think we should give him a challenge. So I was thinking of let's have him just do an assortment of things.
Okay.
I want to see like a typewriter. An airplane, one of those buttons you pressed across the street, to turn the light,
and maybe
the Rosetta Stone.
Yeah, I was going to say the Rosetta Stone.
Yeah, you were going to say that too? What a weird coincidence that we both thought of the same random thing. I can't believe that. So Bob, live, backstage, he's going to do it. Here is your tip of the week.
All right.
I'm amazed that that quickly.
He's literally back there. Must have just put it together.
He's just there's a film strip just feeding in, and he's just drawing things.
Yep.
I think that's how live video works like that.
All right. So for the tip this week, this tip came about because we were getting ready for some of the demos, and you saw Scott gave a service bus relay demo, and in that demo, essentially, we're creating a WCF channel factory and a WCF channel on top of it. And one of the things that you'll note is that these channels can get essentially can go into a faulted state, and when they enter a faulted state, you need to do something to recover from it. And so what I thought is I put together a quick post to really reinforce this, but I wanted to go through kind of the progression of where we started and what occurred, like what went wrong, and how we modified it to get to a point where we had a robust way of handling the faulted channel with WCF in the service bus. So if you take a look at this very first code segment right here, you're going to see this is essentially the code that you'd use to open up a request, or basically open up an endpoint on the service bus. There's a few things here that aren't basically being captured. They're actually in the web.config file, some of the binding settings, binding behaviors, but this is essentially it. You'll see we create our service URI. This is how we interact with the service bus. We create a customer channel factory using that service URI, and then out of there we create a channel, and then we open the channel. Now, this works
good,
great.
ship it.
Yeah, it works.
I'm happy.
It works really well. The problem is with each request to that service, we're opening up we're basically opening up the channel again. And opening up the channel is an operation which can take 2, 3, 400 milliseconds. And when you want to build a really snappy UI that may be hitting this WCF service, it slows things down a little bit. So what we decided to do is modify this slightly so that rather than opening up the channel every single time, we could use a static variable and check to see if the channel had been opened. So you scroll down here a little bit, you'll see now that's exactly what we've done. Up here we've got statics for our channel and factory, and then we check to see if they're null. If they are null, we'll go ahead and open up the channel, and if not, we'll just call the operation, get customers against the channel.
That looks even better. Let's ship that.
This works great, except that once in a while,
you're such a downer, Wade.
The channel will enter a faulted state. So if you go to call get customers on it, you'll end up getting, you'll get an error.
And why might this happen? I mean, this might happen because on the other end nobody was listening, or there was a network error.
So in the case of Scott's demo, if you were on the Service Bus Relay website and you wanted to show the list of customers, if you had ever taken down or closed the service running on premises, so the console app that had the service host and was running the WCF service, if that closed and then reopened, the channel would be faulted because there's no longer now a direct relay between our website and the channel. And so you'd have to handle that faulted state and do something. So we essentially evolve a little bit to get to this point. And there's a little bit, pardon me, there's a little bit more code here. So I'll go in a couple of steps. So here you'll see we still have the statics, but now what we're doing is we're first saying if the channel factory is null, go ahead and create the factory. So this is now just on the factory, and this really should only happen once. And then what we do is we've got some retry logic that we've implemented, and we're basically going to say, you know what? Let's make sure that we try at least 3 times before we effectively throw some sort of exception. But then we're going to check to see if the channel is null or not. If it is null, meaning it's the first time, we're going to, or if there had been a fault, we're going to go ahead and create the channel and open it and then return the customers. If for some reason the channel is faulted, we're going to catch it on a communication exception and we're going to abort the channel. So we're basically going to reset the channel, we're going to abort it, and we're going to set the channel to null. When the retry logic then in the while loop comes back, now we're going to see that the channel is null. We'll create a new channel and we'll try again. So this is a much better way to do it. This gives us the performance we want so that when the channel exists and is not faulted, we get a nice snappy F5 experience. And if something were to happen and it aborts or it's faulted, we abort and recover.
So this, will you finally? Can we ship this?
Yes, we can ship this.
We can ship this.
So,
okay.
Yeah.
And speaking of which, let's ship this show.
Yeah.
So thanks to the people who are here. Thanks for everybody who's online and everyone who watches this in the future. A future thank you to you. And we'll be back on Channel 9 as we are.
Next week.
Every week we do that.
Yep,
I'm going to be out of town next week, so we'll talk about that later.
All right.
Thanks a lot.
Thank you.